Hello, everyone. Thank you so much for joining us on today's webinar, Next Generation Cloud Services for Reducing Supply Chain Risks. This special webinar event is brought to you in partnership with Micro Focus, Microsoft, and Carahsoft. This is going to be an exciting live panel discussion with our experts today. So if you want to learn about next generation cloud services, you're in the right place. We want this to be an educational event, and we encourage your questions. Before we get started, just a few things that you should know about the platform here. My name is Dave. My name is David Davis of Actual Tech Media, and I'll be serving as your host. Again, thank you so much for joining us. The questions panel is there in your audience console. I see many of you already saying good morning and hello from across the United States and around the world. Of course, we appreciate that. We're going to be doing a dedicated Q&A session at the end of the presentation, so get your questions in early. We also have our best question prize that we're running again today for a $50 Visa gift card. And so each question helps to enter you in that drawing. Of course, you must meet the prize terms and conditions, as well as for our $300 Visa gift card door prize that we'll be announcing the winner of at the end of the live event. If you're watching this on demand, of course, the drawing has already occurred. And then finally, I want to remind everyone to check out the handouts tab there in your audience console for more information. Now, before we get started, I want to first introduce you to today's panel of experts. Welcome, Mr. David Ray, Public Sector Chief Technology Officer at Micro Focus, Mr. Sajit Mohanty, Senior Director for Microsoft Federal at Microsoft, and Mr. John Fangi, CTO for CyberRes Federal at Micro Focus. Thank you so much to the experts here on our panel for joining us. I'm first going to hand it off to Mr. John Fangi. Let me bring him in. John, are you there? Great to have you.
I am. Davis, thanks so much and welcome everyone. So today we're going to focus on the new attack vector, which everybody is probably well aware of, the supply chain risk in software. And unlike historical perimeters on the network side, which by and large, both commercial entities as well as the federal government has done a great job of ensuring the security of, the software supply chain is much more murky and unknown from a pure risk standpoint. I'd like to, if you will, organize the kind of thoughts, the dimensions of open source vulnerabilities into four areas: scope, age, unused libraries, and quantity of suppliers. So real quickly, the scope of the problem: 90% of commercial software applications currently for sale right now rely on third-party libraries. And on average, those third-party libraries comprise 2/3 of the actual lines of code. The age of the libraries, so as you well know, keeping the libraries up to date in the supply chain risk scenario isn't necessarily within your control. You're depending on the supply chain suppliers, the software suppliers, to maintain those libraries that they're sending to you. On average, in a recent study, the third-party libraries were over 2 years old. That's on average. Next, unused libraries. So less than 1/3 of libraries classes within active libraries in the products that were studied were ever activated. And in total, less than 10% of the third-party code in the applications was ever used at all. So a significantly greater surface attack perimeter than is necessary. And then finally, the quantity of suppliers. If you look at commercial applications in GitHub as an example, on average, there's over 200 dependencies. So it may be an unknown dependency which actually causes the majority of the problems. Based on the National Counterintelligence and Security Agencies, there have been over 200 known breaches in the last 18 months. SolarWinds was just one of those. So the problem is significantly greater than any one vendor, and there's no specific vendor responsible. It's really the systemic reality of a very, very long and broad software supply chain. You see here in this graph a summary of some of the more interesting breaches. And this chart in and of itself and the accompanying documentation from NCSA is actually very useful, I think, for most of the folks in the CISO organizations and CO organizations to help their leadership understand the scope of the problem. So you see here the examples given, the incident, the entry point, and the compromise stage. Notice the compromise stages span design, development, deployment, operations, and retirement. So it's not just a design problem or a development problem or a production problem. It spans the entire gamut of our reality of IT software. So that's broadly speaking. Now, a number of you, many of you on the call here are actually in state, local, and federal governments. And we wanted to highlight in particular, setting the stage, what are the unique challenges? So the total number of attack vectors is usually a multiple of the programs and applications within an agency. So if you can just imagine, within the federal government, there's 450 agencies, and let's say that there are just 20 apps perhaps of interest and note. And each one of those 20 apps at a low end would have 20 suppliers. That's 180,000 attack vectors right there. For larger corporations who are joining us today, you probably have a multinational presence, different operating companies, et cetera. The same type of equation can be used to calculate how large your attack vector could be. DevSecOps and software factories are typically local to a program or a department, and really don't leverage enterprise-wide capabilities. One great example and exception to this is the Air Force, which, if you haven't studied it, is worth actually looking at, because they've created this enterprise capability and enterprise standards such that when there's a vulnerability detected, it's known exactly where and how to address it at the aggregate enterprise level rather than in each program or, if you will, dev team. Open source software is heavily leveraged, as we all know. These, in the most recent event, not to pick on any one particular vendor, those libraries were pervasively used throughout the federal government in hundreds of departments. Multiple tool chains and software factories do increase the risks exponentially. And in our consulting as well as implementations with federal and local and state governments, it's probably the number one problem that we see. That is the ability for every development team in every department to basically decide their own tool sets and effectively create vulnerabilities that are unknown at the aggregate enterprise or agency level. When you have multiple contractors and cloud service providers, that increases the software supply chain risks. If you've got three providers, you probably have 3 times as many risks, or 3 times the attack surface. And then finally, last point, insider threat modeling, which is hot and very impactful when done well, usually excludes DevOps and IT administrators. And as we saw in the most recent incident with SolarWinds in the winter, that was a key dimension of escalating the privileges as well as exfiltrating the key data that was stolen. And with that, having set the stage of how big and problematic the issue is, I want to turn it over to David Ray for solutions to these problems.
Thank you, John. Well done. So with Inside Micro Focus, we took a look at our product development lifecycle and our software supply chain several years ago, and we identified several functional areas which are actually the attack vectors that were mentioned, by John. And part of the reason of doing this was to find ways in which we can be more efficient in our product to lifecycle, process, but also to reduce risk, and especially within the supply chain, but also to improve our ability to innovate faster, as you would with any agile and digital transformation. When you look at some of these attack vectors and the open source software that supports them, we've seen a lot of CVEs that were introduced into some of these CI/CD automation products, like Jenkins, Puppet, Chef, just over the last couple of years. So it's a tremendous problem when you're a large product development company like Microsoft or Micro Focus. We're a $3 billion entity with well over 300 products, over 8,000 developers, in about 500 teams, worldwide developing, software. So things like Fortify and ArcSight and our host connectivity tools and Serena, all of our load testing tools, Load Runner, we're producing this software daily, sometimes 2,000-3,000, patch releases a year, and on average about the same, anywhere from 1,500 to 2,000 releases a year of our software. So it's really important to us to understand these attack vectors so we could secure them, efficiently. So some of the things that we decided to do several years ago, which we benefited from, when we had some of the software supply chain breaches that were catastrophic, this year actually benefited us. So in some ways we were somewhat lucky because we started this initiative back when we were at Hewlett Packard before the Micro Focus acquisition. And over the past 3 to 4 years, we've been working very hard on eliminating some of those attack vectors, reducing our risk, and improving our process. So some of the things that we've been doing is developing cloud-based repositories internally in our private cloud for our source code. We also have some public cloud sharing that we do with customers for content and updates as well. So we both private and public cloud, repositories. And then we also have a pretty centralized artifactory for our binaries and our software build environments. We've been documenting a lot of the attack vectors as I spoke about, and we're trying to eliminate as many of those attack surfaces as we can. So if you have hundreds of teams, each doing DevOps locally and doing local builds, then you have potentially thousands of attack surfaces, that are vulnerable. So our goal was to centralize and create enterprise services and promote some of the local DevOps excellence that we had in our teams to become enterprise-based and enterprise services. And then we took a good look at our trust model internally. Who has access to source code, who has access to binaries, who's changing libraries, who needs to change libraries, and then locking that down so that we had kind of I wouldn't say a zero trust model, but a shared trust, a very shared trust model among the development teams. So if I'm working on one product, I don't have visibility into other products, and if I don't have rights to actually edit or update a shared library or a component unless it's needed, within my role. So we eliminated a lot of those access points to our internal libraries. And then we also wanted to align better to government standards like the CMMC, compliance standards for some of our SaaS solutions where we're providing services, back to the government, and our data protection compliance for SOC 2 and some of the other ISO compliances that we were establishing, as well as NIST 853 for our FedRAMP authorizations. And then we wanted to actually do a continuous code signing as a service module, so that when code was signed, it was done through a very secure process and treated it like a transaction that was auditable. And eventually, most recently, we're trying to develop a kill chain across the entire build process, so that if there's vulnerabilities that are discovered throughout the build, we can kill the process or nullify the code signatures, so that we can our customers won't assume signed code is correct. And then through this process, we actually discovered a lot of innovation within our products that we needed to add in order to be able to provide some of these enterprise services. So, for example, in our Fortify offering several years ago, we did not have the ability to have a central repository for all source code, nor did we have any machine learning or AI to be able to reduce false positives across all teams that were in the central repository. So we've added several new offerings since we began this process to be able to use some of our tools for performance testing, security scanning, and even our value stream management and PPM as enterprise resources across all teams, so that there's less local application development builds when services are available. Today we have over a dozen services, and I'll talk about that in a moment. And then the last thing is we're moving to a very real-time risk analysis and adaptive credentialing model. So instead of just provisioning credentialing when to give people access or not give them access to a whole set, we're constantly using our insider threat tools, which is our Intercept, product, to look at activity that developers are doing, and then removing credentials or demoting their credentials based on user behaviors. That's a new area that we've been focusing on. We may have some offerings for that soon. We have rolled out some cloud offerings based on that with some of our partners like CrowdStrike in the cloud. You can just simply turn on the insider threat modeling if you're using CrowdStrike. It'll leverage some of our offerings to do that today. So if you look at where we were, this is kind of an interesting use case. As I mentioned, we began this effort just after the acquisition of HP Software by Micro Focus, and you can see a good picture of the problem. We were really green in only one area, and that was in assurance, where we had one tool or one process area. In some of these other areas, like in our quality or development lifecycle, you can see we had over 86 tools or over 31 tools. Now, if you have 86 tools, that means you probably have multiple teams using different tools. Probably have a multiple of that in the amount of processes that may exist, and each of those processes needed to be secured. This isn't much different than a normal a commercial company, or even inside a federal agency or state and local government, where they're developing custom code. Each project or program, as John had mentioned, may be doing local builds, or may do the builds in an isolated area for a team. But there may be hundreds of custom, application development projects underway, which means there's thousands of vulnerable processes. So our goal was to rationalize these. So we leveraged our IT value chain, which is a standard by the Open Group, the same group that produces TOGIF and some other enterprise architecture standards. And we mapped our products to the open standard, to all the IT functions that exist throughout the lifecycle, which is plan, build, deliver, developing a service, and run. This is a high-level view of those. If you're interested to learn more about IT for IT and how it can be used for software rationalization, I encourage you to go out and check out the Open Group site and some of the content that's there. But it's a pretty robust reference architecture that gives you a very prescriptive way of how IT should run, and it's process agnostic. So we were able to map our product offerings that we were using internally to the IT functions and define the data objects, the service models, and the KPIs that existed in the reference architecture to rationalize the tools, whether they met the standard or they didn't meet the standard, or they could be leveraged on an enterprise basis. And we were able to rationalize over 200 products and several thousand processes to a dozen, which we have today. And we've also created multiple enterprise services over the last 2 to 3 years. So things like using something like GitHub for enterprise software secure code repository is something that we could then promote internally to everyone, as well as have a collaboration portal and some other objects. So this is kind of what it looks like today. Since we have most of the products ourselves, we wanted to drink our own champagne and develop our own suite of offerings. But we realized our customers probably aren't going to be using all of our software. So we wanted to make sure we had content for different offerings as well. And then when we had gaps, like we did with enterprise source code collaboration and control, we brought in other products like GitHub and Artifactory. We did not choose to fight battles over the IDE or the open source libraries. We choose to secure those as we could. And for things that made sense as an enterprise service, we established them. So in a lot of agencies and commercial companies, they're using things like Git and Azure DevOps to be able to centralize source code. But few are doing enterprise performance management or engineering and enterprise performance functional testing for their custom releases as a service. They're also not doing source code scanning as a service, or any of the scanning of some of the infrastructure containers as a service. It's usually done on a local DevOps level. There's lots of examples where you're sharing a repo or sharing code among groups, or sharing, how to do scans and how to do automation. There's lots of examples of that, but there's not a lot of examples of removing a lot of those attack vectors that we discussed earlier. So over the last 3 years, we're able to do this, and now we're in the process of being able to offer some of these services back to the community through our cross-sell offerings in Azure with Azure DevOps. So you can actually stand up, our Load Runner Cloud offering to do performance engineering, or our Fortify, software enterprise repo as well as our audit assistant to reduce false positives across an entire line of business or even an entire enterprise. If you can structure your acquisition contracts correctly to handle that. And then where we did a whole lot of work was on the ops side, using our ITOM portfolio for all the provisioning, hybrid cloud management, and the monitoring that we're doing within our network operations management products and our operations bridge, as well as our ArcSight portfolio for our real-time event management. And we've created a new division internally. If you haven't caught that on some of our titles, but there's a cyber resilience package that we now offer with some assessments. It's a different business unit where we've consolidated a lot of our cyber tools specifically that are tightly integrated, in our environment. So our goal is to start rolling out more of these enterprise services through our partnership with Microsoft and other cloud providers to do a better job with our customers, make it easier for them to consume these types of services in an automated fashion for DevOps that are enterprise based. And the last thing is we're working very hard on analytics. So we've been leveraging a collect once, store once model for those analytics that spans across the entire gambit of products you see here. But we can also pull in data from other offerings as well that align back to that IT value chain standard that I discussed. So today we're doing anywhere from 10 to 20 million lines of code that we're scanning nightly. We usually do the scans when they do the check-in, so we don't wait for the build to do the scans. When they're doing the build, we will do the provisioning automatically. We'll also do a series of functional tests, which are automated through our Load Runner Cloud, as well as performance testing, if it's warranted, as part of a package. So a lot of that is done automatically as services for the developers and treated as a service. Each of these services that I discussed has a business owner and a service owner, just like every other service that's being offered back to the business. That was one of the things we realized is you can't just establish services and expect developers to use them. They need to be treated as a production asset. You need to have training, you need to have artifacts set up around it, a service desk for the services that exist with subject matter experts that are available to help people, through the process. So it was additional resources, but in the end, it was also a lot of savings. And so today, we went from 1 to 2 releases per year per product to almost, we could do a release a month per product through this cycle if we wanted to. We're typically averaging about 1 release every 2 months. And again, we're producing production software. It's not just a simple change to a custom app. We have to have all the training and the deal desk and the SKUs and documentation up to date as part of that release package, where most of the effort goes into on those releases that we do every 2 months. And the other thing we realized, we could automate a lot of our compliance processing, because we're both ISO compliant as well as working on our FedRAMP offerings for our SaaS solutions, and our compliance effort that we started about a year ago for CMMC, for supply chain risk management. And we're currently contributing some of the things we're learning about that and some of these use cases I talked about back to the NIST community for software supply chain management improvements. So hopefully you'll hear more about that as NIST starts to publish some more best practices and guides. And with that, I'll introduce you to Microsoft with Sujat Mohanty.
Hey, Dave, thank you for that. And on your prior slide, you were discussing shifting left and going to continuous validation. So it's actually a fantastic point. So given the enormous cost of breach in today's world, so you can see that as far on the bottom here, where we talk about remediation costs from development to build, test, QA, production, breach. The cost of breach is extremely enormous. So it's important to actually bake in security early into the SDLC. So especially the closer you can get from the development side as part of your build processes, as you discussed, and in multiple different points, it's extremely important. Given the scarcity of security researchers, so the fact that there's over 40 million plus professional developers and 70,000 security researchers, You have 570x more developers than you do have security researchers. So it's important to actually address those security concerns early in the development process. And part of that is ensuring that the developers have the appropriate tooling to be able to detect vulnerabilities and fix those, and ensure that we're not introducing vulnerabilities or trying to mitigate those as soon as possible when they kind of hit our code base. So, a couple statistics that have just come through from the industry. Some of our own data shows that 62% of libraries present in applications are not necessarily used by the software at all. So they may not necessarily pose a risk because they're not necessarily compiled into the application, but there's a large portion of vulnerabilities that still pop up. It's important to have an entire life cycle around wrangling your code, being able to scan it, and be able to assess it through its entire life cycle. The average Java application, for instance, has over 50 open source vulnerabilities. So open source provides, a fantastic opportunity in order to drive things like innovation, but it's important to understand what fundamentally is going on. And so here what you're looking at is how innovation can rely on this aspect of collaboration between developers. So the ability in order to take an idea, be able to develop it very rapidly and get it into production is very critical for that feedback loop. And especially around gaining feedback for continuous validation, as Dave talked about in his last slide. And so the Air Force, for instance, has adopted, and the DoD has adopted this entire DevSecOps reference architecture, which allows for multiple industry standard solutions from organizations like Micro Focus and Microsoft in order to actually enable government agencies and also anybody in industry in order to rapidly innovate very quickly, get their applications into production, and adopt cloud native techniques. So one example of this, though, is 99% of the apps with greater than 1,000 lines of code make an extensive use of open source. And so roughly 10 to 20% of the applications that are actually of the code base of the applications that are being built is actually coming from inside of our own teams. So it's important to empower organizations. That's part of our motto at Microsoft, for our organizations, in order to understand what's going into your repository, being able to wrangle what's coming from outside, and also providing the best of breed tooling for enabling collaboration for developers. And we do that through GitHub as one of the offerings. With GitHub, Microsoft, for instance, we're able to address that 10 to 20% of the code base that's actually written by the organization. But then also for respective applications, the influence of open source coming into that paradigm. And when we talk about just as a hyperscale provider, Microsoft is definitely a trusted enterprise platform by our developers. Visual Studio has been a #1 developer tool in the industry by millions of developers for a number of years now. The GitHub, the scale of which GitHub is leveraged by the developer community is upwards of 40 million developers. And I think that number is actually north of 50 million as of this year. And then when we discuss some of the offerings that we have across platform as a service, there's a number of different offerings that organizations like Microsoft provide. Things like Kubernetes as a service, app service, for instance, being able to take third-party cloud native platforms and being able to run those on our infrastructure as well. So there's over 100 services that Microsoft Azure enables for our developers in order to run end-to-end everything they need across infrastructure, platform, and additional capabilities like function-based computing, managed databases, containers, AI-based capabilities as well. So being able to actually enable that gamut of capabilities for our customers and for some of the use cases that Dave and John talked about is extremely critical for us. So when we discuss things like developer tools, it's important in order for us to enable capabilities like the integrated developer environment. So being able to, when we talk about reimagining developer productivity, so GitHub becomes a fantastic example of this, being able to actually provide that repository for organizations to wrangle their code, but also being able to provide the IDEs. So being able to provide things like Visual Studio Code, which we just released within the past 2 years, has become an industry standard as far as a choice of IDEs for organizations. But you have to be able to enable developers to be able to quickly publish and test rapidly on the infrastructure that they're leveraging. Several slides back, you saw multiple different architectures as far as how Micro Focus had enabled their SDLC. You saw the methodologies, the tooling, the proof points that Dave had spoken about. And we enable this for our customers in multiple different service types. So when I talk not just platform as a service, but also being able to do that across databases, containers, AI, for things like MLOps as well. It's important in order, whether you're building a web application or serverless-based solution, be able to actually gain that feedback and create that continuous validation loop. And that also flows into being able to debug after deployment. So being able to easily find bugs in your code, being able to leverage tooling from Micro Focus, for instance, being able to actually scan. So whether you're working with like a Java application, so Fortify, for instance, was called out, being able to do static dynamic code analysis, being able to actually leverage some of the Microsoft tools for like Snapshot Debugger, and being able to intelligently trace through it and walk through code steps. It's extremely important to be able to have that in the same landing pad that you use in order to land your production application. And then when we talk about developer collaboration, and we touched upon this with GitHub, increasing collaboration is one way of being able to get multiple eyes on a code base and be able to actually increase that feedback loop. So you're actually able to make your inherent application much more secure. You're breaking down the silos that can cause things like water scrum fall. So the idea of being able to have a lot of pent up risk before you have a deployment in some dev test or production environment in order to gauge feedback. So by breaking down those silos, we actually enable the ability in order to run fast, run hard, enable innovation, and enable collaboration. And by doing those 2 points really, really well, you enable higher developer satisfaction. And so what we're talking about is developers being able to be empowered and also really enthusiastic just about their entire SDLC, being able to manage how they actually deploy code, take it through all the stages, and inherently start to build much more secure applications. And so what you're looking at here is an example of a first-party software factory that is tied to the DevSecOps initiative. So being able to plan, deploy, build, test, develop rather, build and test, and deploy, and do that across a number of different Microsoft solutions. But respectively though, especially around the development and the testing phase, Micro Focus provides a slew of solutions that Dave talked about, Fortify and a number of others that are very critical as part of this lifecycle. So the combination of the two companies really enables organizations in order to actually adopt that reference architecture and ensure that they're able to actually reduce supply chain risks as they build the next generation cloud native architectures and applications. So whether you're planning, for instance, with Azure DevOps, as Dave was talking about, being able to actually insert your developers into that planning cycle, have them collaborate with GitHub as a code repository, and there's GitHub on-premise, GitHub as an enterprise service as well with GitHub AE. So there's multiple different deployment mechanisms you could use with GitHub. And then being able to actually go through the build and testing lifecycle, so across pipelining, being able to tie into all the different testing tools that Micro Focus provides, and for planning. And then when it comes time to actually building my container, so I've got Azure Container Registry, I can actually use my pipelining to actually deploy from a continuous deployment standpoint into one or more cloud native platforms. So Azure Kubernetes Service, for instance, Azure App Service, and also do that across multiple different form factors. So what you're looking at here is an example on a hyperscale form factor, but the same destination point for deployment could be an Azure Stack Edge or one or more different portable form factors that we provide. So that actually allows the enablement of building secure applications from not just the hyperscale cloud, but all the way out to the edge, and build a lifecycle of multiple value-added and more complex services as a part of that deployment. And so with that, I'm now going to turn it back to John, and we're going to open it up to the panel for discussion and answer some questions.
Thanks, Ajit. That was wonderful. I really appreciate the time and content. So we do have a number of questions. If anyone out there in the audience does have additional questions, please get them in quickly via your web browser application. So first up, I'm going to summarize the question here because it combines two slides that each of you spoke a little bit on, and that's the impact of the design process on security. How is that relevant? How do you achieve that low cost of addressing security early on in that design phase? What does that look like? Security by design is a buzzword. What does all that mean?
Well, I guess I'll start. That's okay, John. I like to think about it as like security by definition, more so than security by design. The difference is that you should have a very prescriptive, defined approach for your build of your infrastructure, as well as the leveraging of secure components in your code libraries. So if you know your libraries are secure, you have secure code routines that you use, and a secure build process, that's all part of security by definition, is the way I like to call it, which can even include your runbook automations that are, from an ITIL, perspective. It's building security into that entire process. So it's not just doing it during the design phase. It's having the ability to audit that you're keeping pace with security. You're monitoring, for those security events, and you have practical remediation steps when things occur. So, for example, when you're deploying an environment, knowing that you're doing insider threat analysis on the administrators and the development community, which was new for a lot of organizations. What do you do when you see somebody emailing screenshots of code outside your organization? He's trying to bypass the source code control tools. He has read-only access to code, but he wants to, share, doesn't want to print it. But we can detect things like that now, which we really weren't doing, 18 months ago. We weren't focusing the lens of our insider threat modeling, outside of, our end users in our environment, not necessarily our developers. So there's an interesting standard called Zero Outage in Europe that I'm a big fan of, the ZIOS standard. But that is all about security by definition, if people want to read more about what that is.
Yeah, and Dave, those are some fantastic points you talk about. It's not just in the build, but also the deployment aspect of it too. So when you mention audit, the idea from a certification and accreditation standpoint around having inheritance for the architecture, so that ensuring that if I've got an agreed composable set of components that I've scanned, I've assessed for the vulnerabilities, I've got my pipelining, but I've also, if I use things like immutable infrastructure for my operating environments, and also the buildup of the containers as well. So when I go and push, it ensures I have a very clean environment, and ensures that I don't have inheritable artifacts that are making their way, finagling themselves into the supply chain. We now have the ability with automation to flatline operating environments. So taking that code and then actually deploying it into those environments around the operating system, eliminating the vulnerabilities there, eliminating vulnerabilities on the code base itself inside the container, now ensures that you actually now have an operational run state that's very secure. So it's not just looking nice and pretty from an audit standpoint, but what's actually running, quote unquote, on the ground is actually extremely secure. It's extremely safe.
Yeah, that's a great point, Such. The compliance effort is really only the first step. It's more of a validation that your things are running, but it's the ability to have a kill chain. To
Yes.
look at every transaction that's occurring throughout the build. I'm thinking at some point it may be some type of blockchain technology that's built into a build process, especially around the code signatures that's issued to a piece of software, so that it's assumed valid. I think we need something like that in the industry that will give us the assurances we need that somebody didn't inject malicious code or has access to inject malicious code during a build that gets signed, which is what we saw in the infrastructure breach in that vector this year. So very scary. But some type of kill chain in the next 18 months for sure. Maybe it'll be a product offering. So, but definitely internally.
Absolutely.
All right. Moving on to the next question. This one says, I'm a new Fortune 500 CIO. Given the importance that you've reflected in this presentation, where should I focus in the next 90 days to reduce my attack vectors and attack surface?
You want to go
Yeah,
first on that?
yeah, maybe I'll get some thoughts, and then Dave, if you want to kind of round it out. So that's a fantastic question. It's kind of understanding what is your attack surface, right, relative to your organization. So I know we talk very heavily about a federal government-based perspective or regulated industry-based agency or operating entity. But if we think of just even a commercial type operating entity, there's multiple different attack surfaces you need to be aware of. So the software code base is extremely important naturally. So understanding, and that's been a big aspect of the presentation, is the supply chain itself, but also the operational run states of systems. So being able to assess vulnerabilities in your code base, being able to assess vulnerabilities that may occur across your operational infrastructure. So whether that's on your cloud-based infrastructures, anything that's running on premise. And what I'll caveat that with is there's a number of different solutions, not just for Microsoft, Micro Focus. I know Dave will go into these as well, from just being able to operationally baseline security, but being able to be proactive. So that's why you see such a big push around taking things from on-premise to a hyperscale provider or moving to a hybrid-based fashion, because organizations like hybrid cloud vendors have pioneered security at scale. So being able to ensure that we limit that attack surface as much as possible, provide the best tooling as required, and make it a repeatable process. That's something that keeps CIOs up at night all the time. And Dave, if you want to maybe talk a little bit about things like ArcSight, the vulnerabilities, other things.
Yeah. I mean, there's two aspects. One is monitoring your environment to understand where your vulnerabilities are, and that's where things like ArcSight, where we can do real-time, assessment and analysis for insider threat, as well as events and CVEs that exist. But probably what I would do first is understand what you have, which is capture an as is on your tool baseline, and simply look at that and where the CVEs are. So, for example, if you do that query and it turns out 80% of your software development teams are using Jenkins, for their builds, or perhaps they're using, Selenium, for some of their testing. Take a good look at those products and the CVEs that exist, and make sure at least you have a common baseline or repo set up, so that people aren't downloading the products outside your organization. They have to go to the repo, and then put some policies in place so you can at least have a central repository. And then what makes sense is probably the things that are easiest to roll out as an enterprise service do first, such as using GitHub as a central repository would be a good step, and then take the repositories away from a lot of the development teams. And that may already exist in your organization, but you will have some outliers. And then probably the most important thing is, if you're going to stand up some type of enterprise services or software factory, make sure you have a business owner and a system or service owner itself. Don't just let it be an IT thing. It needs to be driven, from the business, and you need to have the application owners that are providing the business capability buy in to the concepts that you're putting in place to improve risk, improve quality, and speed innovation. Because those are the reasons that we're doing this, to reduce cost as well. But one of the benefits is, with that centralization, is the reduction of those attack surfaces that exist throughout that build process. And then I would really look to the cloud. If you have a small enough team, you could create a build environment in the cloud that everybody has to use. In other words, you don't do any local builds. You have your build machines configured in the cloud, and they're secured and shared, so you can control those images and the software that's on them. Because one of the biggest vulnerabilities is what's on that person's laptop when they're doing the build. If they're doing it locally, that's a real fear, to try and keep at least for your developers, to keep that clean. But anyhow, we're available to help if you want to reach out.
So that question spawned a very quick one, which is multiple choice. So this says, if I can only budget tool purchases for 2 tool purchases next year, which of the 4 would you pick? UEBA, SOAR, static code analyzers, or privileged access management?
Oh, wow.
Yeah, it's difficult in order, without understanding the broader context as far as the programs, the initiatives, right? I mean, if I just had to purely take a zero trust methodology, one of both, right? If I'm doing things from a supply chain standpoint, and the other from a from a ZT, zero trust identity standpoint, it'd be the privileged access. The other would be some form of a code scanning tool.
Yeah. Yeah, I kind of agree that I would definitely deploy an open source based code scanning solution, and centralization of that. That would probably be my first choice, but I lean more towards the CI/CD and the developers, more so than on the ops side. In operations, automation and mitigation of a SOAR process is awesome if you can get there. Um, I, that's a pretty big task to roll out a SOAR process. It's usually a journey over several years, because you have to understand how you're going to mitigate vulnerabilities and then automate that process through the service desk. Um, it's not something you're going to do quickly. So you may buy the software but not see value for 2 years, and it's also reactive. It's not proactive. So anything you're doing on the SOAR process is something that happened in your environment. You're either trying to fix or mitigate, right, or protect or remove technical debt. Whereas if you're preventing things during the build process, at least you could be preventing a breach from occurring through good security by design, practices. So it may minimize the need to mitigate from a breach with a SOAR process. So, but yeah, I agree with Suj. I have to learn more about how big, how wide, how deep is your organization.
Would you help? You offering?
Sure.
Okay. Yeah. All right. So next question is, I'm a program manager in a federal civilian agency on a large IT program. Isn't CDM taking care of these risks as best can be managed?
Well, I'll answer that first. It was, in my opinion, it was never intended to. I felt really bad when I saw all the especially Congress and the public, really blame Einstein and the CDM program for not detecting some of the breaches that occurred. When in fact, I mean, their job was to aggregate known CVEs and communicate them across agencies to raise awareness, not necessarily to prevent them from occurring, as you may imagine. So I thought that, I don't think it's in their scope, is my quick answer. That's changing, obviously, right? So I think with the new supply chain risk management standards, we're seeing DHS and civilian agencies and GSA now work those clauses into DFARS and into FAR and into other agencies. So it's going to, I think it's going to change over the next 15 to 16 months. So there's preventive measures we can do.
All right, let's see. Next question here. What do you believe are the major challenges that agencies face with improving software supply chain risk management?
Dave, I think you had a lot of proof points early in the presentation. Naturally, I think the challenge is, one of the biggest ones is just wrangling how much code. What's my attack surface look like, right? Meaning that artifact is code. So what do I have in any agency? You've had code developed over multiple decades, potentially, depending on the age of the agency, right? So it's just how exactly do I quantify all those different software artifacts that I have, and also binaries and things of that nature across the different applications. What is the level of applications, the types of workloads that I'll be supporting for that entity, and being able to get the assessment. I think that's probably one of the most important ones that still is difficult for some agencies to adopt.
Yeah, I definitely would agree, Suj. And I guess I'd be amiss if I didn't talk about zero trust and a zero trust model for credentialing and continuous credentialing. That's incredibly important. However, I see that more around a protective perimeter, engagement, as well as protecting some of the applications and access to data. The technical debt issue I talked about earlier, that Suj commented on, is discovering your assets and the vulnerabilities that exist, and then eliminating technical debt is also huge. Just there's a lot of known, publicly known CVEs that exist, and unfortunately we're way behind in keeping pace with those, especially in government. So that would be the second area. And then probably the third that isn't discussed much is you can apply a zero trust model to your data as well. In other words, discovering where you have CUI data, PII data, classified information in your agency and making sure you're auditing against that so that it's protected against the NIST security controls and the NIST 800-171 framework for supply chain risk management. Agencies really need to improve their maturity of those 17 domains that exist in that NIST framework that are mainly structured around protecting data. Eliminating a lot of that data, the redundant, obsolete, information is also key. So it's being able to identify that and eliminate it. That way you eliminate your risk. And I think there's a whole lot of what we call rot, in the industry today that we could clean up rather quickly, especially with some more tools for discovering
Help me out here.
SCR.
Obsolete and help me out here. Redundant, obsolete, and what's T?
I always forget that one, Tom. Thanks for calling it out.
Okay. Quick follow-up question to that one. Could you elaborate on data discovery and the new CMMC requirements for U.S. companies?
Well, Microsoft's probably done a really good job with this already, Sue. But I think it's finding the CUI data and also finding what's called federal contract information. They're actually protected differently. So CUI, you really need to be level 3 compliant. For FCI, a lot of people don't realize you can just simply have an ISO certification, which doesn't require a lot of audits against controls. But I'd like to think that you just might as well protect all data to that level 3 standard that has anything to do with a federal, work product. But that's been a big challenge, for a lot of industry is to be able to discover and find that data quickly and then make sure it's protected.
Yeah, I know both companies have actually published blogs, an entire blog series on CMMC. So we would exhaust probably multiple hours just going through the entire life cycle of things. But I do recommend that folks look for those, especially if they want to go really deep on CMMC and the positioning from both our companies.
Okay. Next question. How big are these problems on mainframe applications, including those that are front-ended by a web-based application UI?
So I'll take this one first, Suj. One of my pet peeves is HSPD 12 has been around a long time. Many of the mainframe apps still have waivers, in place to be able to fix credentialing, the way they'd like to. And for those that have, they're doing things like injecting SAML and doing other things that would never fly, with an N-tier, standard application. So in a lot of ways, I think they're more vulnerable, at least from a protection or access, method, especially when they're web enabled. And most of the people or agencies or organizations are refactoring a lot of those applications to be more or less services to front end web and interior applications. So the integration points are expanding as well, where it's kind of, the lines are kind of blurred about data and access protection over time. I'd love to see people rehost some of those applications in a public or community cloud. And that's one of the reasons we've been working with analysts like Gartner and others to recommend rehost as one of the best options versus refactoring some of those apps, because you can actually establish a lot of the security that exists inherently, in your cloud provider by running a workload, especially COBOL, on Linux or modern architecture. Then you can take advantage of a lot of the inherent, security that you've already built in your normal, cloud apps by doing that. And usually the ROI on those is huge. But yes, it's a big problem.
Yeah, Dave,
Sure.
You hit the nail on the head with that one. It's going down the refactor route is probably a natural fit. You do have to be cognizant because you may be using a microservices with a strangler pattern, and then you introduce a data grid layer, right? An in-memory data grid to be the translation layer. And so now you've incorporated multiple areas that you have to think about. And it makes it difficult for a lot of organizations in order to secure that entire life cycle. So those are just some things to look at as you look at whether am I refactoring, rehosting, or what will be the maturity for the operation of that asset.
Yeah, a lot of people don't even realize the rehost is an option. And usually you can rehost first, then begin your refactor, because then it exposes REST APIs and the things in the cloud. And a lot of the cloud services, from like you mentioned, Suze, you have thousands at within MAG. So you can actually leverage those once you get your application in the cloud. So if it is a COBOL workload, I definitely would investigate rehost, especially with the technology modernization funds that are out there, because the ROI is so high. So it's no longer $100 or $200 million, refractor project. You can usually
Right.
retire a lot of those legacy assets pretty quickly and move it to the cloud first, and then begin the refactoring.
Okay, next question. This may be our last one. How exposed am I in general if I'm using MSPs, managed service providers, for most of my corporate apps like NetSuite, Oracle, and SAP?
So did you want to take that one?
Yeah, sure, absolutely. So I mentioned it before. I mentioned using the term hyperscale providers, but really managed service providers. If you're using a top tier managed service provider for the most part, they have enterprise security teams that specialize in the security of their customers, security of their managed services infrastructure. So from an attack surface standpoint and overall security, you're probably going to be in a pretty good spot. Don't get me wrong. There's vulnerabilities that occur at multiple different points. Something could occur at the managed service provider based on something that's not secured appropriately, something inside of a customer tenant as that's positioned. But for the most part, moving to managed services, and I'm going to do this independent of workload that was identified, is a safer approach than trying to do all the security in-house, unless you're able to, because the real challenge is actually doing it at scale.
Yeah, I'd concur. It also depends on the size of your organization or your agency. There's you simply can't keep pace with the threats and vulnerabilities that are out there today if you're a mid-sized business or a mid-tier business. So the faster you can leverage cloud services, even for the build process or for software assurance or your perimeter protection and keeping your applications there, you're probably going to be better off than trying to bring in talent, which is expensive, to be able to run a lot of those security operations in-house, which unfortunately today, unless you're a large enterprise, you're going to be treading water to keep alive. So
wonderful. Listen, thank you guys so much for the interactive Q&A. I'd like to turn it back now to Davis for closing.
Excellent. Thank you all so much. Very, very fascinating discussion today on this event. I appreciate David, John, and Sujit for joining us today. Thank you to the audience out there for all the excellent questions. We appreciate it. And of course, thank you to Micro Focus, Microsoft, and Carahsoft for supporting our event today. Before we go, I do want to award our Visa $300 gift card that's going to Francine Popovich from Arizona. And we'll reach out to our best question prize winner as well after the event. Thank you, everyone, for being here. Have a great day, and we'll see you next time. Bye-bye.
Thanks, Dave.